Right, okay, so let's look at this lab on tunneling and basic web security. So the first thing that we're going to do is to look at the SSL Labs assessment of sites. So this is a useful site because it does the testing for us, and it will generally grade and find any weaknesses on a site. So if you pick 3 sites and then define how you're going to scan them, but we'll just have a little look at one of them. So let's have a look at this one here. Okay, so we can see here that this is getting a B overall, and the weak areas are key exchange and cipher strength. Certificate is excellent, and also the support for protocols are pretty good. But you can see here the reason why it's been capped at a B. So normally the forward secrecy is to do with the usage of the RSA encryption for passing the key back. And we can see here it doesn't support this AEAD cipher suite. Okay, so we should be able to see the grade, the digital certificate, and the size. So the size of the key, so it's 2K keys for RSA, and this is the signature that's on the certificate. So the signer will take a SHA-256 hash of the certificate and then apply their own private key onto it to sign it. Then the public key of the signer will then be available to prove that they actually signed for the key. And so does the name of the site match the name on the certificate? Hopefully that's the case in this case, or it wouldn't be getting such a good grading there. In terms of the expiry date on the certificate, so we can see here it expires in just over 11 months. In terms of the hashing method that's used on the certificate, so that is, we should find that, so that's our SHA-256 there. And the E value that we use for encryption, remember for RSA we take the message to the power of E mod n. N is a multiplication of our 2' numbers. So the value that virtually all RSA methods use is this value here, 65,537. Any weak ciphers? Well, the good thing here is that actually this site has dropped off any SSL support and TLS 1.0 and 1.1. But here we see a weak area in our cipher, and it's weak because we're using a key exchange method using RSA. 128-bit AES is good, and SHA not so good there. In this case, SHA-256 is good, AES is good, but it's the RSA key exchange part which is winning here. In terms of the losing of the weak ciphers there, in terms of the methods that are defined for each operating system, we can see that most are supported well. There's no SSL2 on this one, and there's no TLS 1.0 and 1.1. And we can go down here and find out if the site is susceptible to beast, poodle, and so on. There's no RC4 used, there's no vulnerabilities around heartbleed, and so on. For some of the more up-to-date security headers that could be used. There isn't any application of that in there. And then at the very bottom we've got all the elliptic curve methods that are defined. Okay, so that is an assessment. So go ahead and do your own assessment from there. So the next thing that we'll do is that we'll now run some, we'll do the same, but we're going to run some Python code. So obviously it's inefficient for us to go, if we had control of maybe hundreds of websites, or we had to scan, it's going to be very inefficient for us to go and run that GUI every time. Okay, so what we typically do is that we will get some scripts, and we're taking this script here from this site, and we're going to run the same test against those two sites. So we'll just go here, and I just find out where I am. .07. Okay, just to get the most up-to-date code, I'm just going to pull. Well, I won't bother doing that. So you can do a get pull to get the latest code, and we'll just have a look to see if we've got a code here. And there it is. Okay, so if you want, so what we do is that we set up initially sites.csv. Okay, so that's the first line, which will define the name, the column names, and then the second one will just put the name of the site and then the main name. So it should scan cloudflare.com and bbc.co.uk. So once that's run, once that's finished, then get your code to here. I've created a copy of the code. So it's just taken from a GitHub. And what we're going to try to do is to then use the SSL Labs API, pass the name of the site that we want to scan, and then it should do it for us. So it will take a few minutes. It might take 5 minutes to get a scan for each one, but what I've got here is actually an output. So the output should go into out3.txt, and we'll just have a little look at that. It looks like a JSON format there, but eventually you should see the output going into that file for all the sites that you're scanning. So just to show you that all the details are there. So there's the one for BBC. And we get details such as the grading and other things, all the things that we saw before. So there's the logjam flag there, there's Heartbleed, there's all the elliptic curve methods that it's supporting. There's the certificate details, and so on. So if we had time, we could parse through this and create up a database of our results from our scan. Okay, so have a look at that and see if you can get that to show you the results of your scan. So the next thing that we'll do is we'll open up google.com. So we won't do it yet, but we need to start up our Wireshark here. Okay, so we're just going to capture the connection to google.com. That's our network adapter there. So we'll just get that started. And then we'll open up google.com. Okay, so there we go. That's it. And then we'll go over here and we'll just stop that. So now what we've got to do is to be able to find that connection. So I would normally do flags.send. Okay, so we see here, this is the start of the SYN-ACK, and then ACK, and this is on port 443. Okay, we'll see a few connections coming through because it creates multiple connections for the content to be downloaded. It just doesn't create one. It'll create other ones for the kind of parallel gathering of the data from the site. So your IP address, so this is your IP address 10.214.0.96, and Google's is this. We're using port 47602 and Google is using 443. So we now need to find the SSL version that we're actually using. So we just let's quit from here. And now we need to look at the client hello. Okay, so we're using TLS 1.0 on there. So we can have a look to see what Google is using. And Google is using TLS 1.2. Okay, so the client is sending in TLS 1.0 and we're receiving it back in TLS 1.2. Hopefully either side will be able to support each of the contents. So we need to look at the encryption method which is used for the tunnel. And we should find that here. Okay, so it's using AES 128 GCM with SHA-256. That's the negotiated cipher suite. And if we look back at the client hello, we should be able to see the suites that our browser can support. Okay, so you see a lot of elliptic curve in there. Cha-cha 20, there's a elliptic curve method. Elliptic curve with RSA is a good method to pin the certificate onto the key exchange. So there's the 18 methods that have been defined by the client to be able to connect. And in the server hello, we see the final version. So it's 128 AES with GCM and using SHA-256 as the hashing method. So now we need to go back. Bring up Google again. Let's have a look at the connection in there. And hopefully it should be the same as what we saw. Okay, there we go. There are TLS, AES 128, GCM, SHA-256, and TLS 1.3. Okay, so in this way we can see that Wireshark has given us the same results here. So do the same for Twitter, twitter.com, which should default to HTTPS always. And we'll just have a look at this one. There we go. and we've got elliptic curve Diffie-Hellman with RSA. So RSA pins the verification, so there's no man in the middle for elliptic curve. The RSA makes sure that that we are contacting the website that has passed the certificate. 128 AES GCM and SHA-256. In this case, we're only using TLS 1.2. Okay, so the next thing we'll do is we'll use OpenSSL to kind of do the same thing. So we'll just stop Wireshark, and we'll just open up a connection. To live.com. Okay, so it's given us some details there. So we should be able to look to see if TLS 1.2 has been used. There's the cipher suite, elliptic curve, Diffie-Hellman with RSA is the key exchange method. 128-bit AES GCM is the symmetric key method, and SHA-256 is the hashing method. We're using 2K public keys for our certificate, and let's see if we can see what type of method that we're using for our keys. And there, so we can just scroll up and have a look. That's the certificate chain, and we need to see is the keys. So we should find that we're using 2K RSA keys for our elliptic curve. Keys are much smaller than that. Okay, so symmetric key method is a 128-bit AES GCM. Hashing method is SHA-256, and that's and who signed the certificate. So we should see that up here. So we can see it's DigiCert Global CA as our top level signer of the certificate. Now what we'll do is we'll have a look at some of these files and try to analyze them. So let's see if we can get these files, and I'll show you one, and then hopefully you should be able to see how the other ones work. So it's our security site. Okay, so there we go. So there's the SYN, SYNAC, and the ACK. So our address is this, the server's address is this, our port is this, and the server's port is that. 443 is the standard HTTPS port. If we follow the stream, we should see the server hello and the client hello, and we should see the details of that. But after the negotiation of the tunnel, it should then be all encrypted. So the next thing it's asking is for the SSL version that's been used. So you can see it's TLS 1.0 is the eventual method. So the encryption method that we'll be using for the tunnel will be contained in the server hello. and it's RSA, yuck, with 3 des, EDE, CBC. That's the symmetric key method, and we're using SHA-1. So RSA is weak, 3 des is kinda weak, and SHA-1 is definitely weak. The hashing method is SHA-1, and the length of the encryption key is, if it's 3 des, then it's 56 times 2, which is 118, if you check. Okay, so go ahead and have a look at the other ones. I'll just show you the client hello. So the client hello should show us the cipher suites. And there they are. So these are all the cipher suites that our browser or the client supports. And what can happen is that a browser can try and pull these down to the lowest security level, and then if the server agrees to that, then it could cause vulnerabilities. Okay, so have a look at these ones and see how you get on. So the next part of the lab is for us to create our own TLS infrastructure. So just let's see where we are. Search the key. And then we want to do we have a command for E? Just let me see if I've generated a certificate first. Good, I have. Okay, so we generate a certificate initially from this command that we've used before, from this command. And so that will create our public and our private key. So if we go here, and then we're just going to paste that in. So that's, we're going to create our certificate. It's going to be valid for 365 days. The output is myset.pem. UK. Just take the defaults here. Okay, so then what we have now is our output keys. And the certificate. So what we're now going to do is that we're going to run our server with our keys, with our key pair, and then we're going to get the client to connect to the server, and then we'll pass it something like a get that would simulate what we would ask for with HTTPS. So we'll just run it here, and I think I've got some code already defined. I'll just show you the code first. Okay, so you might find there's something already sitting on 443. So I've moved it to 444. So we'll just give that a try. E01 server. Sorry, that's the wrong password. Okay, so we'll just park that there. In fact, let's get Wireshark running first so that we can capture this transfer if it comes over the wire. Sorry, put the wrong password again. Okay, so E in this is 168 is our main interface. Let's get our server running. We may not be capturing on the right interface here, but we'll give it a try. Try, and we're going to connect to port 443. We'll have to check out what our IP address is first. 96, that looks okay. 96, okay, so make sure you have the right IP address in there and the right port that we're going to connect to. So all that we're going to do is to be able to connect to our server, which would obviously be on another machine, and we're going to send a GET. So a GET is just the GET HTTP request for a URL. Okay, so we'll try running that. I don't think we need to run it in sudo mode because it's just a client application, but we'll give it a run. And that's it. Okay, so I captured off the wrong port, so let's see if we can capture it. We go for the loopback connector. We could try for any. There we go. Just stop that. Okay, so the connection is there. We've missed off the first little bit. Here it is here. Okay, so the connection that I've just made was between the client to the server on port 444. That it's there. And then there's the SYNAC, there's the ACK. We then see a client hello, so that will come from my machine, from the client there. We can see the ciphers that are being offered to the server. There's the certificate that we created earlier. And you might be able to pick off, there's internet widgets and so on. So there's the cert that we sent. And we see the cipher suite being picked here. Okay, so that's going to be the cipher suite for the connection. If we look, and we'll just save that. Save. if we look at the server, the server's the one that's going to be picking off what it actually wants. So we can see here that what it said is that there's no TLS version 1 or no TLS version 1.1, and what we want is AES plus elliptic curve Diffie-Hellman. So if you have a look here, you can see that we selected 256-bit AES. Even though the client was offering 128, we selected that, and then when it came to the elliptic curve Diffie-Hellman, we can see here it's selected one of those. Okay, so in the client hello, we were offered all of these, of which 128 AES is included. But because in our server we actually defined a policy that actually said what we were accepting, we've only accepted 256-bit AES. Okay, so have a look, and also we don't want any TLS version 1.0 and version 1.1. So hopefully when we've negotiated it, it's TLS 1.2 that we're using. So that shows that the server didn't allow 1.0 and 1.1 and has selected 1.2 there. Okay, so have a look. You can change the different cipher suites that you send within the client, that will be accepted by the server, and we can take set ciphers equal to high. So if we change the set ciphers equal to high, in here, it will only take the best crypto possible for that. Okay. So for the last one, last part, we'll look at ifconfig, and our IP address here is 10.214. 0.96. Okay, so it looks like we're running HTTPS there on 443. So just to show that we're running that. HTTPS. We can see this shown as insecure, but it's because it's a self-signed certificate. So what we'll do is we'll add the exception. And there's our sample page. So we can go into /var www. And then into HTML. Oops. We just change this. Just to prove that it's taking it from here. Sorry. That's it. Okay. So now what we'll do is that we need to now connect to the SFTP service. 192.14.0.96. So our present working directory is that. We'll do an ls to see what files that we've got. So we'll go into sftp user. And now I'm going to put that file to the folder. Okay, so we'll go to home Napier. Okay, so a default was in home and then Napier. I think I put the file into here. So we'll just change the, I should have copied it into Napier, but change the mode . 755. Okay, so I've used SFTP to be able to upload the file to there. So now what I'll do is I'll try that again, but this time I'll record the connection. So I don't actually have that file in there, but you shouldn't be able to see the contents. Just let me exit from there. Okay, so we'll put the file that's in there, and that's uploaded, and then we'll exit. So let's have a look to see what we get here for our SFTP. So we can see we're using port 22 to do our FTPing. That's our SSH port, and here is the connection. So we can see there's the protocol that we're going to be using. Okay, on the other other side. And we're using Cha-Cha 20, Poly 1305 for the stream that we're going to have, and there's the key exchange that we're using. We're using an elliptic curve 25519 for this key exchange. Okay, and there goes the clients. There's the keys being generated, and then once they're generated, then it should all be encrypted, and we won't be able to see anything. So if we follow the stream, okay, so we can see the negotiation in here, and then eventually it should all be encrypted from there. But the negotiation itself is negotiating the basic ciphers and also the key stream method that we're actually using. Okay, so go ahead and see if you can get your HTTPS server set up.